And good morning, all my wonderful friends. Oh, hang on. My audio level is always too high to start with. It's probably distorting. Welcome to Bayswater, which, as Michael pointed out, has neither bays nor water. But I still say the name is aspirational. Maybe with a bit of global warming, this could be like the edge of a bay or something. Bayswater. But Bayswater is the traditional lands of the Whadjuk Noongar people. So before we get into anything, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, who have we got this morning? Michael, of course, I've already said hello to. Scott, Sion, Johnny, Stephen, Imogen. Oh, Imogen said hi from outside the box as well, so I assume that Chip is around somewhere. The Lane, I've already said Stephen. Family plans. I don't know if I know family plans. New viewer. Austin, Nassim, Luminator, Johnny, DIY, Graham, Sharky, Tony. Oh, Tony, you're here. Awesome. That could be really, really helpful today, given that I am going to just be stuffing this up from beginning to end. And Dodgy's here and many other people. I probably missed a bunch of people in the chat. Oh, having tech chat issues. Okay. So maybe we should get everybody to beam in and we can do some remote tech support. Hopefully you resolve whatever that problem is. Now, I feel like it's drink time and I've been on the air for like 30 seconds. So I hope you're all having a really good weekend. It's been a fantastic weather here the last 2 days after all of this rain. It's probably going to rain again today, but right now it is looking like pretty close to the perfect day. Apart from, there's a fly buzzing around me. It's going to drive me nuts. Okay. Austin said, great timing, just finished blending the milkshake and just sat down. Sitting there with a milkshake. Nice. Austin said, that's a heck of a beard growing. Yeah. Johnny says, getting more and more like my beard every week. Yeah, it's kind of got to a tipping point, and I was clipping it probably about once a week up until just recently, trying to stop it from getting out of control. But I got to this tipping point where I've kind of decided, shave it off entirely, full Kratos, and I think I'm going to have to go full Kratos, just for a little while at least. Okay. Unexpected maker. So Sion said Bayswater. Yeah, there has been a lot of water around here. Graham Brown said, what is King Lake also missing? I bet King Lake has no king, no lake. Sharky, talking of water, how's the floating floor? Yes, the floating floor. For those of you who don't know, I'm living at my sister's house at the moment in a little apartment that she's got, which is on the basement level of the house. And part of the floor in the kitchen area is tiled, part of the floor in the living area is floating floor over the slab. And it flooded really badly about 2 weeks ago, give or take, when we had that huge, like 70 millimeters in under an hour, I think was the rainfall. It was just like, and the floating floor was actually floating on water. So I was walking on it, there was water on top of it as well, but there was water under it. And as I was walking on it, there were sort of waves on the floor and it felt like walking on a waterbed. It's really bizarre. Anyway, Mike, Mike Garden said the fly paused the video. What happened? Seeing your name there, Mike. Yes, I've missed the last couple of weeks with Tony doing Muay Thai classes. I've been loving the classes with Tony. So much fun. And what happened was it 2 weeks ago, which was good. And then yesterday there was no Muay Thai class, which made me sad. Oh well. Yeah. The floor that floats. Yes. So it has mostly dried out. And the thing is that so I ended up with a layer of mud on the floor. We had to literally just scrape the mud off the floor and insurance assessors have been in, and they're probably going to have to rip out all the cabinetry in the kitchen, rip out all the plasterboard up to probably halfway up the wall. Oh, I can see a warning that the bit rate on the stream is really, really low. So there are definitely internet issues going on. Internet issues. Can anyone hear me? If the audio keeps coming through and I'm just looking like a frozen person, that's kind of okay. I can keep talking. But if the audio drops out as well, then that is a real problem. So maybe we've drowned the internet. Cool. Yes, audio is fine. That's great. Oh, Henrik is here as well. Fabio from Brazil. Nice to have you here. Oh, audio stops when video stops. Okay. All right. I am going to forge on, and hopefully this internet problem is going to clear itself up. We shall see. Internet is like a big, yes, as Michael says, the internet is like a big dump truck. It's not like a series of tubes, it's like a big dump truck. You dump stuff on it and then you take it to somewhere else. Now, what are we going to do today, brain? Take over the world as always. So, I have here, sitting on the bench down here, we have the prototype of the wireless access point. Sitting in the base of its case. I've put all of the headers and things on it. It's actually upside down. Not that orientation makes any difference in this case. We've got the header here for the Raspberry Pi. I've put on the Power over Ethernet regulator module that you can see there. It's got the Ethernet connection, power jack, there is the mode button, and it is just generally ready to go. And we have a Raspberry Pi here, which has an SD card in it. And I've made a duplicate of the image from my previous prototype for this project. And so that's what's running on here. So my plan for today is to power this up and mess around with the peripherals and just see what we can talk to, because there are a few things. The most important obviously is Ethernet. We need to be able to talk to this WIZnet chip so that we can communicate via Ethernet from the Raspberry Pi. So the Pi has Wi-Fi, but it does not have onboard Ethernet. So, I'd better silence my phone. Notifications from Jazzy. No. Thanks, Jazzy. I will get back to you. It's not like she's watching the stream anyway. Where was I? That's right. So we've got Wi-Fi. We can bring this up on the wireless network and then SSH into it to mess around with it. But it doesn't have onboard Ethernet because it's a Pi 02. So we need the WIZnet chip working in order to have wired Ethernet, which is rather important for an internet access point. Wired Ethernet. Did I say wired internet? Wired Ethernet. Brain fade. Okay. We've already previously validated things like the power supply part of this. We know that we've got 5 volt and 3.3 volt rails. Power is all good. And I've got a USB OTG cable here because I had this, when I was getting this set up off stream, I had this plugged into a keyboard, and somewhere around I've got a video, oh here it is. Here is a it's a mini HDMI to HDMI adapter. I had that plugged in as well so that I could see what was going on. So we should be able to get into this on Wi-Fi. Let's just start doing stuff. Enough blathering and talking. More action, less talk. Okay, so we've got that in there. I'm just wondering if I should unscrew the baseboard in case I need to get access to these ports, because one of the problems is that the edge of this enclosure prevents me plugging this HDMI adapter in. I just can't get the angle. But I don't think that's going to matter because we're going to SSH into it anyway, and hopefully, Actually, let's, yes, I will unscrew it because I'm not even sure what the IP address is. Although I could find that out. Whatever. I'm prevaricating. I should be just doing, not thinking. Not thinking, not overthinking, which I always do. Okay. So, I'll get it out of its enclosure, at least then it's easier to mess around with. Now, I want to... so tempted to say break free then, but no. I want to power it up and find out what IP this is on. So, just for the fun of it, I will probably just get this out of my Unify list of devices, but somewhere here I should have an HDMI cable lying around. Where is it going? Maybe I don't. I had an HDMI cable here which I had plugged into the ATEM so I could see what was going on. Maybe I need to grab another HDMI cable. That's okay. We will go for a little walk all the way to about 2 meters away from my desk where I have a box of HDMI cables. And I think this is the cable I was using previously. Get myself another channel. What channel am I going to put it into? Oh, Tradie Trev is here. Nice. Forget RGB, Johnny. Yeah. I have been ignoring the chat as usual. With ATEM Extreme, do you have both the multi-view and a program out? Yes, I do. The ATEM Extreme is awesome. Thank you to the anonymous donor. That is such a cool thing. All right, so we've got HDMI out here. Now the thing is that I haven't set up all of the multi-view stuff, so I can't, I can't yet overlay as many different things as I want to. I've done some of the setup, but not got it to the point where I can do all the things I want. All right, so we have HDMI. I have, this is the output from my bench power supply, so turn on the power supply. What have we got it set to? 12 volts, 2 amps. That'll do nicely. I'll just plug that in there. And now, if I power this up, in fact, what I'm going to do is go to, on the ATEM, what am I looking at? I'm going to go to channel 1, 2, 3, 4, 5. Let's go to input 5. No, not input 5. That's the other camera. Input 6. Yes, okay, this is the one we want. So input 6 and then turn that on. So what we're looking at here is the HDMI output from the Raspberry Pi, which is currently powered off. So I'm just going to hit power, and now hopefully it'll wake up and we may even be able to see its output. If this works, come on, does it work? Is it booting? What's it doing? I don't know. I see nothing. I see nothing. Do I even have it on the right input? So that's 7. No, that's 8, 7, 6. Yes, it is the right input. All right, we're not getting any HDMI coming out of it. Do we have activity? I wasn't paying attention at the appropriate time, so I really don't know. Oh yes, we do have activity. There is something going on. Okay, we just don't have any HDMI out coming into the ATEM, which is unfortunate. Oh yes, we do. I was on the wrong input. I just counted across the wrong number. Okay, so that is the desktop of the Pi. Now, that doesn't really help because I don't have a keyboard or anything. But let's have a look at, okay, that's a nice vista, isn't it? I wonder where that is in the world. Looks like a place worth visiting. Have we applied electrons? Yes, we did. I just had not applied my brain. So, where are we going with this? Where we are going is that I need the IP address. That's right, that's what I was doing. Now, I'm going to see if I can log into my... what is the IP address? Oh no, it's on localhost. I'm going to log into my Unify management console, maybe? If I can remember. I can't even remember what the local management console thing interface is. Yeah, I'm going to have to do this the other way. I'm going to need the OTG cable, and I'm going to need a mouse and a keyboard. Oh, there's a mouse just here. Okay, maybe I don't need the mouse. If someone can tell me what is the keyboard shortcut to open a terminal on Raspbian OS. If I can get an answer on that, then I don't need the keyboard. I think I used to use Control T or something to open the... just pulling a keyboard out of a pick and place machine. Yeah, it was something like Control T would open a terminal on the GNOME desktop somewhere, I can't remember. Okay, Control Alt T, Meta 3, Control Alt T. All right, I will give those a try before I bother with plugging in the mouse. We'll see if we can go straight to the console. No, not console, to a terminal. Of course, we could go to a console, that would achieve the same end result. All right, keyboard is plugged in. So, what are the, yeah, Control T, I think I've tried that and it doesn't work. No, so Control Meta T, nope. Control Alt T, nope. Meta, oh yes it did. It just took a while. Okay, so let's see if we can, I was just trying to zoom it a bit so I can read it. Shift Alt plus, no, that doesn't zoom. How do I zoom it? There we go. Aha. If config, and I want to do grep for 192 because I know it's going to be on that group. Okay, .234. Hooray, progress. So now I'm going to switch to away from the Raspberry Pi desktop and go just to this. And new terminal. And once again, let's invigorize it. 234 was the IP, wasn't it? So we want to go to, I don't even know what the user was. I assume it was Pi. 68.1.234. Is this it? Yes, it is. Okay, so we are now SSH'd into the Pi over Wi-Fi. And we've got just a single WLAN interface, just configured as a regular Wi-Fi client, I think using WPA supplicant, connected to my office network so that we can get access to it. So, at least now we're, as they say in the hacker movies, I'm in. And now, this is my notes file. In fact, so this is the one that I did not show last time because of having confidential information in it, including passwords. And then I realized that the only password that it shows is like a one-off password that I created just for a specific test image, and I don't care anyway. So if anybody sees that password, it's not going to give them anything that matters. So in this file, hang on, let's get out of this. And all right, this file is my grab bag of notes that I was using. So I just put all sorts of stuff in here. Okay, and what you can see here is when I do things like try to get something working, I will just, as I'm going through steps of running commands, I will just copy and paste them into a notes file, and then I've got a record of what I did to get to that point, whether it works or not. And it can be really useful to find things that don't work as well. So this, for example, it says previous failures below. So this would have been following this particular tutorial, and then I tried to do this stuff, and for some reason it didn't work. I don't know why. But up here I've got this comment that says this works. So it's from this Adafruit guide, and I don't even know if this has been done on this this particular image. So let's try it. I'm going to zoom that one in bigger again. So just as a starting point, let's try to get the temperature sensor working. If we can read from that, then we've made some progress. Collected blinker. Thank you. And we're going to need CircuitPython MCP 9808, which is a temperature sensor that is now unobtainium. So for the next revision of this, I'm going to have to switch to a different temperature sensor. But this will do for now. All right, so let's install the MCP 9808 MicroPython thing, and then let's try. Once that's done, we'll go into Python and try these other commands. Hopefully this will all just work, and then we'll get some, hang on, which Python? Well, that's useful. Python version 2. Let's run this under Python 3. So we'll do, let's just import some stuff as it says here. I'm just blindly copying and pasting at this point. Just seeing what happens. I don't even remember how I got to the point. Okay, so that's failed. So what we are possibly doing, we may not have I2C enabled, no hardware I2C on SEL SDA 3.2. So, boink. Let's try Raspberry. I can't remember if I can enable it through here. Can I enable I2C through? I have a feeling that I can. Yes, enable. Would you like it to be enabled? Yes. Okay, that may make things work better now. So let's go back and run back to Python, do all this stuff. I want to do that third thing as its own line just so I can see the error. All right, so this one, this is where it exploded last time. Hey, it didn't explode. That is, that's a step forward. What have we got here? Oh, now it's exploded again. So MCP equals, this is where I am way out of my depth with this stuff. So having you around, you can all help me debug whatever is going on here. Oh, in Myanmar, okay. This is talking about the desktop image, so talking about this desktop image that is behind that terminal. In fact, I'm going to exit out of that terminal. Control D should do it, yes. So that desktop image, where was that comment? Oh yeah, so Austin said the background images from Old Bagan, which is a city in Myanmar. Yeah, nice. Okay, back to here. Where, okay, now we're into Python debugging hell. So what have we got here? I wonder if, I don't think so, but I was just wondering if it's a like a permissions problem. A lot of the time things like this sadly go away if you run them as root, but I don't want to do that unless it's necessary. Another, during handling of that exception, we've got this exception, and then we've got this exception. No I2C device at address. All right, no at address 0 hex 18. So the first thing to check here, I just want to make sure that I am using hex 18 as the address for the MCP 908. Oh wait, oh hang on, I just had a thought. I wonder if there even is an MCP 9808 on this board, because when I populated it, it would have been fairly recently, and when the 9808s were no longer available. Let's do something different. Let's just do a scan. Check if that's enabled. So first thing is, yes, so we have a bus. We have an I2C bus, which we already know. So let's do I2C detect on that bus. And we do not have device 18. That is interesting. So we've got 31, 48, and 50. Okay, so it's no wonder that the Python driver freaked out and couldn't find it. It's not even there on the bus. Now, I've just opened Eagle, so we will now have a look at... Going to have a look at these design files. Where? It's alphabetical. Yes. So I should be able to find it. You would think. Alright. So here we go. Let's bring this up here. Oh, there. And have a look at what we've got. So, temperature sensor. Ah. Well, this explains it. The reason that it is not working is because we don't even have an MCP 9808 temperature sensor on this iteration of the board. So, a little bit of background. So, the MCP 9808 is a formerly easily available I2C temperature sensor, which comes in a variety of packages, including SOIC 8 and also some smaller ones. You can get it in a little QFN, and there's some other package, I can't even remember its name, some very small outline thing. And it became unavailable, but the AT30TSE752A is a pin-compatible I2C temperature sensor, and so I ended up putting one of those on the board instead, and I changed the part number in Eagle. So what address did I set on that? So it's AT30T, so it's pulling all of those to ground. Normally, when I was slacking this one, obviously, but normally what I do is in the schematic make a list of all of the I2C addresses, or all of the peripheral addresses. So what I should have done here is noted the I2C address of the temperature sensor here at the location of the temperature sensor. But then I also typically have a list. So usually on the first sheet of the schematic, what I'll do is I'll have a chunk of text somewhere on the schematic that is just a list of all of the devices across all the sheets. So you can look at that list and see, oh yeah, this is the address of the temperature sensor, this is the address of that MAC address ROM. I haven't even noted that down on there. That is really slack. So back in, if we go back to here, so we've got devices at address 50, 31, and 48. Keep in mind though, these are hex addresses. It's so when I say 48, it's not actually 48 decimal. It's 48 hex. So One of these will be the temperature sensor. So let's have a quick look. AT30 TSE. I'm gonna, oh come on. Okay, I'm gonna add a browser here. AT30 TSE 752. AT30 TSE, there it is. As you can see, I've had the datasheet open before. And what is the default I2C address for this thing? Somewhere, I should have just gone straight to that datasheet link that was in the results. In fact, what I really should be doing at this point is not even going to the datasheet. I should just be going straight to looking for drivers for it, for Raspberry Pi. I'm wondering if I should defer this and start messing around with the WS2812 LEDs instead. See if I can make those work, because blinking lights are cool. Device communication. Yeah, come on, come on. Where is the address? Address, come on. Temperature alarm, comparator mode. Why would I care about comparator mode before I care about its I2C address? Priorities, people. Priorities. Configuration register. I'm probably just about to get to it, but stuff that I2C. Does that not appear anywhere in the datasheet? Memory addressing. Current address read. Alert response address. I do actually have a better way of finding out the default I2C address on this, because I've used the same thing on other projects with ESP32. So stuff that, yes, that is not worth continuing to mess around with. Let's do Raspberry Pi that and see what we can find. Can we talk to that thing? Must include, yes, must include AT30TS752A. Has anyone done this before? I'd really rather not have to do this from scratch with doing all the register decoding and all that sort of stuff, looking it all up. GitHub topics. What I should be doing also is paying attention to the chat, because there are smarter people than me here and they can probably be telling me what to do. But my feeling on this now is that it's going to take a little bit more digging, and it's probably not riveting entertainment. So, Austin says 48 is temp. Yeah, page 9, small text. Cool, thank you. Yeah, but without some information about a driver, let's just search for, say, a Python driver for that. Nope. I'm going to get rid of that in case. Python code. Temperature. Why are these ones coming up? Adequate temperature and humidity. Let's. Is that just the first match if you search for the word Python? No, it's not. So there is some association between that part number and the fact that this is a page talking about temperature and humidity, which makes me wonder if it does appear, or some subset of this part number appears on that page. But I am not going to keep digging on this right now. All right, let's bail on messing with that for now, and instead, all right, let's try messing with something else. Let's try this one. Okay, so 2812B, do that. I don't know what is installed on this, so let's just, that is, if everybody is okay with me just bailing on the temperature sensor and moving on. Yes. So yeah, A2 to A0 are grounded, so it's the first address in the possible range. Oh yes, of course I need super user privileges. Do it. Do it. Sudo make me a sandwich. And then I want to check. Yeah. Blacklist sound BCM to blah. This may have been done on this image already. No, I don't think it has. This Raspbian image doesn't seem to have anything on it. So I have a feeling that this may actually be a clean Raspbian image. It's not a clone of my previous access point prototype, which is what I thought it was. Because it doesn't have any of these packages installed on them. It's not just that they're out of date, it doesn't have them at all. And if this was the prototype image, it would already have them. Drink time. No, it's not a cup of delicious coffee. All right, let's have a look at, oh, yeah, it doesn't even have Vim installed. That is how you know that I have not been using this image for more than a few minutes. Come on. And no, I am not going to... oh, okay, so Tony said blacklisting worked prior to overlays being implemented, may not even be relevant now. Yeah, okay, interesting. So I am really in territory that I don't know anything about at the moment. Just following tutorials and trying to fudge my way through. Come on, Vim. So, while Vim is slowly installing, what is everybody else up to? Oh yeah, so, okay, now it turned out these weren't the problems, but there were some good suggestions earlier, which, in relation to detecting the device. So, Simon suggested restarting the Pi, and Michael concurred, said, yeah, my habit is to reboot after every Raspberry config change. Yes, so that's a very good point. After doing the Raspberry config change, I probably should have rebooted the Pi. However, we now know that that would not have caused the MCP 9808 to appear on the bus, because there is no MCP 9808 on the board. All right, I'm going to do this blacklist thing anyway. What have I got here? Oh yes, this is something that I copied previously from Tony when I was messing around with it. But I'm going to, we'll get to that. I'm probably going to need serious help when it comes to the Ethernet side of it, because I did mess around with that a little bit a little while ago. Let's cd into Pi, vim main.c, oh hang on, yeah, main.c. Line 60, what do we want to do? We want to set GPIO to 77, 77, and line 66, we want to set height to 1. Okay, yeah, because I've just got a single strip of LEDs here. Whoop, scones. So I'm going to build it. Hopefully this will compile. If this doesn't compile, then it's going to be strike 2. All right, so let's do, hang on. I've got to get this somewhere that you can see it. Okay, I'm debating this. All right, we don't need the keyboard anymore. We don't need HDMI anymore. So I'm just going to unplug that and bring this over here, sitting on my shoulder somewhere, so that you can kind of see it. And then I'm going to run this test thing and see what happens. Does it work? Is illegal for LED channel 0. Yeah, why is it GPIO 77? Okay. Let's figure it out. This is probably because I was running this previously on a Raspberry Pi 3 and the GPIO numbers are probably different. So yeah, so all of these notes that I've got here in this file are from messing around on different hardware previously. This is not actually the hardware that we're playing with now. So let's go back to here and see what is going on with this I/O. So we've got Raspberry Pi 0 headers, LEDs are on I/O 12. Okay. Well, could it be as simple as that? Let's change that to pin 12, scones, and see if this fixes the problem. Okay, so nope. Oh, that's this is the classic sudo make me a sandwich. All right, sudo test. Oh, it's working. Check that out. Hang on, I'm going to stick this onto the overhead camera, or at least it was doing something. I'm not even sure what this is meant to be doing, but it did something with the LEDs. So here we have the overhead camera, and you can see all of the LEDs here are turned on, the 4 of them. I'm going to, you can't see this now unfortunately, but I'm going to kill it in the console, and I'm just going to run that test script again. Yeah, and all that test script seems to be doing is sequentially illuminating the LEDs. Let's, in fact, sorry, you can't see what I'm doing, but I'm just going to have a, yeah, let's have a look. We'll come back in here. All right, so this is the code for that test script. So this is main.c. And what is this thing doing? I haven't even looked at this. Jeremy Garth, thank you very much for your work. So, what's it doing? Version XXYYZZ. It's including a bunch of libraries or headers. There's a WS2811. That's interesting. It's using the 2811 driver to drive 2812s. One of the things that changed between the WS2811 RGB LED driver chip and the subsequent version, which is in the 2812, is they swapped some of the, I can't remember which ones. I think they swapped red and green and blue stayed the same or something like that. So if you don't compensate for that, oh yeah, here we go. Look, this is the compensation. Yes, so it's got defining strip type, WS2811 strip GBR, so that's green, blue, red, instead of red, green, blue. And that is, and this is for RGBW strips. So that's how it achieves its compensation, using the WS2811 driver to drive a WS2812. It lies. So we've got these values, width and height, which we edited earlier. So clear on exit. Yeah, let's do clear on exit. Let's just turn that on. I assume it's a 01 LED string. Blah, 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 blah. Okay, so it's setting up some stuff there, brightness, etc. I'm going to turn that brightness down because it's on camera. It is looking, I'm going to make it like 100. On camera, it is looking really washed out. It just looks like the LEDs are turned on full. To me, it looks like they're a purplish sort of color, but that doesn't show up well. So what have we got then? Matrix render. So we just got a loop in a loop, and it is setting, yeah, this is just because this test is designed for a two-dimensional driver, so it's going to have rows and columns, and it works along whichever way it is. Rows works along each row in, or does it work along each? So on the inner loop, it's doing the height. Okay, so it's scanning vertically and then it steps along to the next row and scans vertically again. All right, so matrix rays, we've got arrange in opposite directions. Yeah, okay, so that's just a weird arrangement. Matrix clear, dots pause. Yeah, okay, not very interesting. Matrix bottom, where's main? I want to see what it's going to do. Pass args, got a whole bunch. Control C handler. Okay, so this is Control C handler here is where it's going to hopefully handle clearing it at the end. Pass args. Interesting. So we can send, oh, okay. Yeah, we can send arguments to it. What else do we have? I'm spending way too much time on this because this is a kind of a secondary thing. But it is interesting. I like looking at other people's work and seeing how they've done this. It's always an opportunity to learn because I couldn't do this myself. I just look at other people doing this sort of thing and admire their work. So we've got, okay, ignore all of that. Setting the GPIO, SD, yeah, okay. Skip all of that, don't care, don't care, don't care. Main, this is where it matters. So it's outputting its version and setting that up, running so it does arrays, bottom render, and that's it. Okay, so what we could do is we could modify this to, I don't actually care. The whole point of this was just to validate the hardware. I just wanted to see if when if we could talk from the Raspberry Pi to those LEDs and have them respond. And we've now proven that that's the case. So anything else beyond that, like controlling them from Python or whatever, we know is a software problem because the hardware is working. That is the critical thing. But yeah, what I was thinking of doing then was just putting in a 15 frames a second. Yeah, we could mess around with this a little bit. While running, we could do something like change the color, put a loop in here and have it increment the R, the G and the B values and make it go through a rainbow or something. But none of that is really all that super exciting. So what I'm going to do, I'm just going to, now that I've edited that, I've turned on clear on exit, and I have, just going to bring it up so that you can see it. All right, I'm going to give you the overhead view, that one, and then I'm going to run this test. Oh, sudo. Always sudo. Okay, so now it is running and the LEDs are on, but they are not as bright as they were before, which is exactly what we want. In fact, hang on a second. Let's activate mood lighting. Here we go, mood lighting. And now we can see what's going on much better. Yeah, that's pretty cool. I like that. One thing that I do want to do while I'm messing around with these LEDs is I want to put this back in the enclosure and see what the glow pattern is like, because that is part of the point of all of this. All right, I'm going to Control C out of this and let's see if the LEDs turn off. Yeah, they did. So the Control C handler worked. Well, we do have a little bit of we have a little bit of progress today. We have some slight success. All right, now I'm going to shut that down because what I want to do is put the Pi back into, boink. I'm just shutting it down. I want to put the Pi back into its enclosure, put the cover on, and then mess around with the LEDs. So we're just seeing the activity light, it's still blinking away. Now it's stopped. So I think the Pi is fully shut down. Let's yoink the power. Oh. And stick this back in here. And I'm going to turn the mood lighting back off. go to full illumination while I put a couple of screws back in place to stop this board falling out. And then we can, oh, come on. It's always hard trying to do things while keeping my head out from underneath the camera. Trying to look at it sort of from the side so you're not staring at the back of my head. Okay, where's the cover? Where did I put the cover? Cover is over here. So, which way? There is one particular way that this cover goes on. I think it's like that. Yes, okay. So the cover is on. I'm going to plug power back in under here. So the Pi will now be booting. We'll give it a minute to boot. Then I'm going to turn mood lighting back on. Now, this is something that I was concerned about. The power LED is fairly bright. And so you can see that this is glowing green. It's showing up on camera, and I can see it fairly clearly myself as well. So when the room lights are on, you can't tell. But when the lights are off, you can see that green LED glowing through. And I really need to do something about that. I might even just get rid of that power LED entirely. Or maybe, maybe we could relocate the power LED to be under the Raspberry Pi, which means that when the cover is off and you're looking at it, you can see it just for debugging purposes, but not have it visible otherwise. Johnny says, yeah, you need to switch to a pink LED, then it wouldn't be annoying. Yeah, or purple. Purple LEDs look awesome. I don't have enough of them though. All right, I think I've given it long enough. I'm going to try SSHing back into it. And so I've got to go into, where was it? Where was, oh, I just realized when I did the all that stuff a moment ago, I was inside the, oh no, I was in the right directory. That's right, sorry. I thought I made a mistake, but I was wrong. So let's just try this testing again. Okay, now I'm going to edit this script. You can see the LEDs turned on there, but they weren't very bright. So I'm going to edit main again and turn that brightness back up because it's not showing through. I'm going to take it all the way back up to 255. So they're going to turn on at 100% brightness. Just recompile. And now I'll turn the LEDs back on. Ka-choing! That looks cool. Now, because the LEDs are in two parallel rows, my concern was that it would just look like two lines. And you can distinctly see that it's two sides of the enclosure that are illuminated, but surprisingly, it kind of looks like two semicircles, even though the LEDs are straight. So it's kind of working out okay. If I added a couple of LEDs at the top part of the board here, so the Raspberry Pi is sitting right here. It's effectively a shadow inside there. Yeah, I don't know. I don't think it really matters. In any case. So I'm just going to Control-C out of that. Have a look in main again. I just want to have a look at where it is setting the color, or is it just turning them all on? When it does raise LED, I know you can't see this. dots, colors, dot colors. So what is it using? Hang on, let's bring you in as well. So we've got LED dot colors, and we've got a few values here predefined, and dots pos 0, 1, 2, 3, 4, 5, 6, 7, 8, which I guess corresponds to this. There are 8 rows in there. Now it's probably using one of these. Now my guess is that what they're doing is using the dots pos value as an index for the colors. Maybe I'm wrong, but let's find out. Where is dots pos used? Dots pos strip blah height dot colors matrix bottom. What are we doing here? Let's work backwards. We're going to, in fact, let's go to main. I'm spending way too much time on this just because I don't know why. Maybe because it's working, so it feels like I need to stick with playing with this rather than moving on to something else that won't work. But that is not how progress is made. That's how you end up comfortable in the circumstances that you're in, and you don't move on in life. What am I doing? That's right. Zoning out for a second. So it prints that. It does a malloc, set up handler while running. So matrix raise, matrix bottom, matrix render. What is going on in matrix raise? That is matrix times blah. Yeah. What about in matrix render? LED string channel 0 LEDs with blah. And then matrix. Anyway. Matrix bottom. Here's the other one. So these are the things that it's doing. Dot pos I. So it's stepping through the positions. I think what we're doing, I see what's going on here. I wonder if we get something interesting happen if I change this so that instead of having width as, let's change this. I was misinterpreting that earlier. What it's doing is stepping through the array of colors, and it is drawing lines on the matrix. So let's go back to here, and this time we should get different colors on each of the LEDs. Yes, that's better. So now we have some more fun stuff happening. Right, yeah, better. Yeah, all right. That's kind of funky and cool. So now we have rainbow effect running on it. So, okay, we can consider that this live stream has been a success now because we have a rainbow. Okay, drink time. And I'm back. All right. Like what I'm going to do is, just for the fun of it, test. Let's see. I'm going to copy test back to my home directory, and I'm going to call it RGB rainbow. And I'm going to set this to run on startup. So if I do RGB rainbow, just make sure it is doing its thing. So sudo vim etc rc.local. Let's see if we can make this work. I'm going to go home pi RGB rainbow, and so that I can send it into the background. Hopefully this will work. Let's find out. Okay, I'm going to now, oh, you couldn't see that, hang on. Okay, what I just did is I made a copy of that test program that we just compiled. I renamed it to RGB Rainbow, stuck it in the home directory, and then I have just edited rc.local so that after starting up, it is going to call it and put that process into the background. So if this works, what I'm going to do is reboot the Pi, but I'm going to reboot it while we're looking at it. Hands off. I'm not touching anything. I'm not going to initiate anything. I'm just going to let the Pi boot. And once it has finished booting, we should have the rainbow coming up. So while that is happening, what else is going on in the chat? Oh, look at that. Yes, success. So now when we boot, the access point is going to go into crazy rainbow flashing mode, and then we know that it's booted. So now I would be able to SSH back into it again. And it's been up for 0 minutes. Yeah. Oh, an Englishman in Brazil said maybe put a piece of silver self-adhesive tape on the inside of the lid. That might help with the green LED glow. I have some of that right here, so I could do that. But what I don't want to do is block the other LEDs. So you can see there's a shadow just there. Something going on inside the lid, and the LED is just there. So I could put a square maybe on the inside that corresponds to that, which would make it, yeah. Now it's a square, now it's a diamond. Well, not really. Yeah, what is that shadow? Oh, I see. No, that shadow is the shadow of those capacitors. See, these big electrolytic capacitors here are being shadowed by that. In fact, for the purposes of making this better, just for now, handy dandy blue tack. I'm just going to stick a thing of blue tack over the green LED. Oh, now you can see the blue LED as well. So we've got one of these LEDs is for the 3.3 volt rail and one is for the 5 volt rail. I can't remember which is which. But for now, I am going to blue tack out both of those power LEDs. And let's see if that improves the experience. Yeah, it does. So I think one of the lessons from this is we need to get rid of those power LEDs in some way. And just have it control, just have the illumination coming from there. Richard says blue is 3.3 volt rail. Yes, thank you. Cool. So Dentistry says, could you add a delayed fade to each LED so you get a nice ring pattern? Yeah. Well, it already has a delay in it. So the frame rate is set in the, so you can see that it's scanning around. Anyway, is it possible to see the blue without blue tack? I'm not sure. Yeah, and an Englishman said the LEDs might overheat. That is possible. I'm going to take the blue tack off the blue one. And no, you can't see that. But the green one is being driven pretty hard. You can see how bright it is. Just feeling the... No, it's not overheating. That's fine. I can't even feel it getting warm after the blue tack was sitting on top of it. So I'm going to stick the blue tack back on them. But I could dramatically increase the current limiting resistors on them so that they do glow, but they're very dim and don't show through. That might be the best way to do it. Okay. Well, it's kind of starting to look like an access point now. One thing that would be interesting is how much of this reflects on the wall behind it, if that was mounted on a white ceiling. Right. Yes, it is very tempting Tradie Trev said, could you make a switch for them? Possibly, but I think what I'm going to do is just add a lot more resistance to the current limiting resistor for the green LED. The blue LED is probably okay. It's very dim already. I think I've got something like a 2K2 resistor on it. And the green LED is probably, I think, yeah, the green LED is on a 5 volt rail, and it's probably only got a 470 ohm resistor. So if I made that like 1.5K or something, or even 2K2, it would glow. You could see that it's on, but it wouldn't show through the case. All right. Well, we don't have a Wi-Fi access point yet, but we do have blinking lights. And blinking lights are step one on the road to world domination. Now, yes, so is it dentistry? Someone asked about the frame rate. Yes, dentistries. Josh said, could you add a delayed fade to each LED so you get a nice ring pattern? Yeah, I could. All right, stuff it, let's do it. CD into here. But then I want to move on and try doing some other stuff because the main.c, somewhere down here in main, it's got a delay. Frames per second, so is dividing 15 frames per second. You sleep. Let's make it slower. Let's make it 5 frames a second, which will make the ring spin much more slowly. It'll stutter a bit, but at least we'll be able to see it. So, although before I do this, I'm going to have to do kill all PSAUX. I just want to see the process. grep RGB rainbow. I think that's what I called it. Kill all RGB rainbow. Is that going to work, or do I need to? Oh, come on. That's better. Okay, so, and as you can see, the LED stopped when I killed that process. So now what I want to do is run the test process. I'll throw you, before I run this, I'm going to throw you back to the overhead view. I'll run it now. And look, you can see now that with the lower frame rate, it's only doing 5 frames a second. You can see the colors moving around. It's like, but it's not very smooth. It's just jumping. What would be nicer would be to keep a high frame rate, but have intermediate colors. It's not just those 8 colors, but actually use RGB values inside counters, inside loops, so that it did a smooth rainbow transition. Although this is not what we're, right, I'm just going to kill that process. Anyway, all of this, it was just to test that the LEDs worked. It wasn't to try to make a rainbow. Okay. Now, yes, I am happy that this live stream has had some success now, at least. Type in like there, fade to the next color. Oh, okay. So dentistry said yes. I didn't see this comment from Josh earlier. What I mean is, so rather than just switch to a new color, there is a fade to the next color. May not be able to notice it with the speed it cycles around, but just a thought. Yeah. So what you're describing is the way it should be done. Instead of having that array of 8 discrete colors and just stepping through the array, it should be smoothly transitioning between them. Yeah. All right. We have now, to my satisfaction, proven that the LEDs are working. So I'm happy with that. And we even managed to debug to figure out the problem with the pins, with the I/O pin being wrong, based on what I had done on my previous testing on the Pi 3B. Now, sorry, I'm just looking around at the screen and what is going on. What am I going to do next? What we will do... Oh, and I do like that now it will come up with a rainbow when the Pi has booted, because one thing about Pis is that sometimes when you boot them you can't actually tell if they've got into a running state. And now we know that once it's executed, it's booted to the point where it's executed rc.local and then fired up the rainbow pattern, we know that the access point is up. That is cool. Oh, this, Richard, this is really generous. So Richard said, looking to gift more memberships. Enough participants here that want them? Considering gifting 10. I control quantity only. You click above chat to claim. First come, first serve, apparently. Well, Richard, that is very, very generous. I really appreciate that. Yeah, thank you. And thank you to everybody else that has taken out a membership on the channel as well. It's that sort of thing makes a big difference to me, particularly with the way things are in my life right now. What am I doing? What am I doing? Okay, I am going to do this and do this so that we can see it. And now we are going to get to the tricky thing. So let's just recap. What hardware do we need to validate? And normally when I'm doing a bring up like this, I have a little list. There we go, the Pi has finished booting. So yeah, normally I have a list, and then I can work through methodically and make sure that everything is working. So on our list, the mode button. So here I've got the schematic for this open. We've got the mode button here, and we want to be able to read an input from the GPIO. So it's on IO 6, and when I press that, the IO goes low. Alright, so looking at this, we have validated the LEDs. These are working, and they're working with the level shifter, which is cool. So you can see here I've got a MOSFET acting as a level shifter between IO12, which is the Raspberry Pi GPIO controlling the LEDs, which is on the 3.3 volt rail, and then we're doing the MOSFET level shifter trick to pull that signal up to 5 volts and then driving that input into the first of the RGB LEDs. So all of the LEDs are running off the 5 volt rail, and it's expecting 5 volt logic on the input. So that works, as we can see right there. There's proof that that little MOSFET is doing what it should. So Ethernet, I'm going to get back to that. Mode button. So we've got IO6, which is being pulled high by this 10K resistor, and then what is going on with this mode button? Why? Oh, I see. Oh, I confused myself for a moment. I couldn't tell what was going on. I was wondering why both sides of this switch are connected to ground, and it's just because I was misreading my own symbol. These two things on the back are not actually electrically connected to anything. Those are just mechanical mounts, and they are soldered to the ground plane of the board. That's just the body of the switch. So we've got 3 pins connected to ground, 1 pin connected to IO6 with a pull-up, so when we press the button it goes low. So maybe it's worth checking that. I do want to validate that this part of the circuit works and that we can read from the IO. Now what else do we have? Temperature sensor. We have bailed on that because it's going to take a bit of digging to find a driver for that. Might even end up having to write my own driver. So Excuse me. MAC address ROM. Okay, so this we can check. We can check whether we can read it. I think I've already done a little bit of messing around with that. What else have we got here? The ID. Excuse me a second. Ah, that's better. The ID EEPROM. So this is the EEPROM that is required by the Raspberry Pi hat specification, and I dual footprinted it just because, you know, chipocalypse. So I've got a SOIC 8 footprint and a UDFN 8 footprint, but they're the same part. You'd only put one on. I've got one of those on the board. I can't remember which. I don't care. They're electrically the same. So MAC address ROM. I think I may have had this working on the Pi previously. Maybe that's the next thing we can mess around with. Let's have a look at... got to get back into it now because... Oops. Because I rebooted it. Okay. Now, where are my notes? Back to the notes. What I'm looking for is the... What's the name of it? MCP 24. Okay. MCP, do I have MCP 24 anywhere in my notes? 9808, 9808, 9808. No, I don't. Okay. I must have done this somewhere differently. Somewhere different. Okay, so it's going to be time to do a quick check. Somehow I keep covering the chat. Oh, DIY, thank you for the cup of coffee. That's nice. Oh, and Richard went ahead and with his gifting of the memberships. That is so cool. So we've got a whole bunch of new members. Yeah. Oh, Tradies a member. Peter Kirkos is a member. Yes. Awesome. Yes, Johnny says, let's have a look at absolutely everything except the chat. 51 is EEPROM. Okay, so Austin has just given me a little summary here. Okay, I'm going to do this. I'm going to keep a record of this. Oop. Now that Austin has done the hard work of doing this I2C addresses, oh, it'd help if I could spell. So, where is it? So, 0x48, temperature sensor, which is, I should put the part number in, just to be precise, 80, where are we, 8030 TSE, 752A temp sensor, and then what else have we got? 0x50 is the MCP 24AA, 025E48, such a memorable part number, Mac ROM, and then the other is the EEPROM. Okay, so I'm going to do this in numeric order. Oi! Come back here. I keep forgetting that I have to hold down Shift and Enter to do a new line in this in Eagle. So 0 hex, where was it? 31. And the part number on that one is CAT24C32 EEPROM. All right. Thanks, Austin. Now I won't have to look them up next time. They will just be right there in the schematic. The way it should have been. And Johnny, Johnny is obsessed with sex for the Pink Power LED Fund. Thank you for the 100 sex. It's so funny how the SEC has become the the currency of super chats, just because it's funny to say. Yeah, I can't even remember what currency that is. What is where SEK, SEK. Where is it from? No, not SEK, SEK. SEK currency. It is Swedish krona. Okay. So what is 100 Swedish krona? $14. Thanks, Johnny. Yeah, I don't know why, but for some reason I thought that SEK, that makes sense. SEK, SE for Sweden and K for krona. But I always assumed that SEK was a currency from somewhere in like Southeast Asia. I don't know why. Oh, and Jeff has become a silver supporter. Nice. Okay. Thank you, Jeff. Right, so where are we? That's right. I'm not going to bother validating that. So there are apart from, okay, let's just do a quick overview. Ethernet status, we've got that, we've got PoE. What's on the far one? That's just voltage regulators. Nothing to validate. We've already validated all of the power stuff here. Power is working, but power is good. But although I don't think I validated PoE. Anyway, that can come. So the thing, okay, let's do a quick review. The things we still need to validate, the big one, the number one, is Ethernet. The W5500 Ethernet controller. And that is what Tony has done a bunch of work on with the overlay. Then we also need to validate the temperature sensor, which I have deferred. We need to validate the MAC address ROM, and we need to validate the ID EEPROM. Now, and the mode button. So there are 5 things still to validate. I'm hoping that reading the mode button is going to be super simple. It really should be. Raspberry Pi read GPIO. Let's just say read GPIO Python. Let's see how much messing around it is to do this. Touch blinker.py. No, I don't want to do that. Codify. Set mode, GPIO out. No, that's controlling a GPIO. I want to read GPIO. GPIO. I was hoping I would be able to just find a very quick how to install LDR pinout. Okay. I don't want to write to the GPIOs. I want to read. I'm pretty sure that in the past I've done this with Python and it has been really, really easy. LED related commands, button related commands. Oh, okay, basic commands. Yeah, okay, so it looks like there is a Python rpy.gpio API library. Examples. Button. Okay, so this really shouldn't take very long. Let's give this a shot. What I'm working from here is this tutorial. Let's get some zoomage. Not that much zoomage. Alright, so this tutorial is for using GPIOs on the Pi. And let's get started. What do we need to install? In fact, what I should be doing is this. Otherwise, I'm just going to have to relearn all of this at some point in the future. Reading GPIO. Let's from here. All right, what are we going to do? GPIO 0 API library, so we want to install that. So I'm going to stick to Python 3 for now, so let's do this. Move my notes aside, back to here. Let's just see if I can do it without doing it. GPIO 0. Okay, so once that has finally decided to do its thing, or read satisfied. Okay, it's already installed. Then import it. Import GPIO 0. Okay, so we've got the library installed. This may be as simple as just doing a really basic thing, and pin 2 is always pulled up by default. Alright, I can't remember what pin it's connected to. Here we go. From blah, im blah, let's, with GPIO 0, with apply GPIO. Okay, two different ways of doing it. Let's just do this. Read button.py. What am I doing? I don't know where Python is. I'm going to take a guess. User bin Python 3. It's probably wrong, but I will fix that. So, and it's not on GPIO 2. What GPIO is it on? It's on 6. So let's change that to 6. And which Python 3? Oh, I guessed correct. User bin Python 3. I know I don't really need to do this, but this just makes it easier to use in future. So let's see if this explodes. There is no explosion. That is amazing. Okay, I'm going to slide on over and grab myself a screwdriver so I can press that button inside the case. What? It's working! How cool is that? That's like instant satisfaction. Get the little dopamine hit. So that script is reading. Let's just do a quick review of cat read button.py. So what we're doing is using the GPIO 0 library, importing button, using sleep, that's just for the delay. So we're setting up a button object and giving it GPIO 6, and then just forever, if it's pressed, say it's pressed, sleep for a quarter of a second, do it all over again. So we can now successfully do that. Okay, I'm going to make a copy of that and stick it over here. So, and I'm going to make a note of the other thing I did, pip3 install GPIO 0. Okay, so what this will give me for future reference is a little concise record of exactly what happened. Install API library, and then I can type good. Script to read from button. Okay, so that will now, at least now we've got a record of how to do this in future. Right. Who was talking about zoomies? Mad Techie. Mad Techie, have you just arrived? Sorry, I had to cough again. Oh, and again. What is going on with my throat? I don't know. Well, that is more success. So let's, I'm going to make some more notes here. Validation. Let's say, W5500 Ethernet to do. Say GPIO button input works. Oh, what should we say? We'll just say okay. RGB LED output. Okay. And just because I do not like when things aren't aligned. Okay, then MAC address ROM to do. We had the Pi hat EEPROM to do. My memory is gone already. We were just looking at stuff. Temperature sensor, that's right. Temperature sensor to do. And MAC address, temperature sensor, mode button, RGB Ethernet. We've got that is done. And I also want to check that, okay, so I want to check that PoE works. So I'll do PoE 12 volt. I'm going to validate these independently. Come on, there's a shift key there somewhere. To do, and PoE 802.3 AF to do. Now, we could validate these power things fairly quickly. So, all right, what have we got? When you look at it like this, we haven't really got very far. We've got button input working, and we've got RGB LED output working. So it's kind of the pretty stuff, but not the useful stuff. The big one, the W5500 Ethernet. I'm kind of tempted to validate the power side of things just to get that out of the way because it's relatively simple. Shall I? Shan't I? Yes, I think I shall. I'm going to grab myself a PoE injector. But before I do, let's do a quick scan of the chat. Stephen W, testing your SPI bus. Okay, import RPi. So Tony had some suggestions about the GPIO input, which is really cool. Then, Cable Tie is here. Yes, good morning, Cable Tie. Scott wants to call you Zip Tie. Mad Techie, have you, Mad Techie and Cable Tie, have you both been out on rides? It's a nice day, my guess. Cable Tie, probably going up Mount Dandenong. Yep. Now, what am I looking for? I'm looking for a PoE injector. And I have a PoE injector right here in my handy dandy PoE box. So I'm going to do 2 lots of validation. I'm going to do it with a regular injector. Like this one, the 48 volt 802.3 AF PoE injector. And I'm going to do it with one of these DIY sort of thingamajobbies. And I want that one. Okay, let's do it with the DIY thingamajobby first, because that is super easy with the bench setup. Okay. Now the mood lighting is kind of cool, but it does make it a bit harder to see, so maybe we should switch to regular lighting. No, but first thing, I'm going to shut this down. So I'm just coming back over to my my console and I'm shutting it down. I'll give it a moment to finish writing the disk. You can see there's a bit of disk activity happening there. It's flashing away, and then after a while it will stop. So then I can pull the power. So what we're going to do now, just to summarize where we're at, I am going to turn the lights back on, go out of mood lighting mode. Come on, that's it. Looks so bright in comparison. My eyes were adjusted to the dark. Okay, so what we're going to do now is power it through the Ethernet cable with nothing else plugged in. But I'm going to power it with the 12 volt. So I'm actually going to use this same 12 volts, but I'm going to send it down an Ethernet cable using this injector. So I'm going to plug that in there, and then I'm going to get a piece of Ethernet cable from there going in into here. And then this whole thing should power up and we should see the spinny colored LEDs again. But under here, there are these two pairs of pin headers. These are the PoE bypass headers, and this is what is required for DIY Ethernet. So I'm going to grab a couple of jumpers and stick them over these. Stick it over there, stick it over here. So now when I apply power down the network cable, it should go straight into the input of the voltage regulator, the 5 volt voltage regulator. So we have short Ethernet patch cable, and we have this. So this, if I plug this in, we should get powered Ethernet, and this is where smoke may come out if I've screwed up. So we can only hope for something that exciting. Let's see what happens. Oh, we got nothing. That is in, oh, I know why. Oh no, I don't know why. I thought I knew why for a moment. Okay, we actually have a problem that needs debugging. That is interesting. So, what we've got, I better just validate that I do have power everywhere. So, where? I'm going to go to here. Yes, I do have power on there. So what we should have is power coming out of this Ethernet socket. I'm going to have to look up what the pinout is. Going to the PoE bypass and then coming to here. So I'm just going to start probing around, and unfortunately, now during the week I did actually start setting up the UT61E interface so that I could throw the multimeter up on the screen up there, but I haven't got it fully sorted yet. What I've done is I've got the interface working so that my laptop can see it, and then OBS can include it, but the green screening hasn't been done yet. But just for the fun of it, I'm going to, where is it? I'm going to power up the interface. This is kind of chasing a squirrel, but that's what we're all about here. Where is it? I need to get power onto, just looking for a convenient place to plug in a USB cable and get some power to the multimeter interface. All right, the multimeter interface is up and running. Over on my laptop, I've got to do this. All right, so what I'm going to do is temporarily switch this input onto camera 8. Boom. And so on the screen, what you can see at the moment is the multimeter up in that corner. And if I grab these leads and touch them, you'll see values start to change. So I have the multimeter interface working, going back into OBS, and OBS is overlaying it with a green screen, and then that is coming into the ATEM. So the next thing that I need to do is set up the chroma key stuff in the ATEM so that it removes that green screen and it uses the original background, which would be like the overhead camera. So that you can see the overhead camera plus the multimeter plus other cameras all at the same time. That's the next step that I haven't actually got to yet. But if I don't even know where I'm looking for here. So what am I looking for? Oh, that's right. I was looking for voltage coming in, and I am not seeing anything significant. So I need to start digging into where these tracks actually go. So, back where? Here. I don't even know where I'm probing for voltage at the moment. So here we've got the power source bypass. These are the pin headers that I just put those jumpers onto. So what I really want to know is where is ground and where is the output of this. I'm going to trace along the power path, not the signal path, the power path. Well, kind of the signal path. So that trace right there, I want to know where that is on the PCB. So where, hang on, I've got to open the board layout view right here. It'll be one of these tracks. Come on, zoom. That's more like it. It'll be one of these tracks right here. Like VB2. I think it'll be that one, because we've got VB1 coming in here from the RJ45 socket, and although this is this is interesting. I wonder if we're getting voltage on VA1 and not VB1. So I'm going to try probing. Where's the ground connection? So when the bypass is in place, VB2 is pulled to ground. Yeah, I'm using VB instead of VA, and I wonder if this injector is only putting the voltage on VA, in which case that would be 0 volts and that would be 12 volts. So I'm going to do that and that. Unfortunately, you can't see much else, but I'm just going to probe across those pins that I was just highlighting in Eagle and see if I've got voltage on those. And I do. That is interesting. Okay, so this particular injector that I'm using is only injecting it on one of the pairs, not both of the pairs. Well, I actually don't know if it's not injecting it on the other pair, but I assume it's not. And of course, assumptions are always bad. No, it's not. That is interesting. So that means I need to do one of two things. Either use a passive injector that puts power in on the other pair, or change the design so that it taps off the VA pair instead of the VB pair. So, Annie Mills had an interesting suggestion. Step 1 of Ethernet cable troubleshooting, try different flying lead. Red is often a crossover cable. Yep, that is a very good point. Now in this case, I know that that red lead is not a crossover cable, but that is 100% a valid observation. And typically red is used as a crossover cable. So just to check, I'm going to go for a different cable. Got another one here, and So I'm going to plug this in here. It'll be funny if it turns out that it really is a crossover cable. No. No joy. No power there. And what I am seeing, so you can see where I'm probing here, although it's not really zoomed in so you can't see much. What I'm probing here is the pair of pins that are, I'll do it again so you can see the voltage. This is the pair of pins that are on the VA pair. That one there and that one there. And you can see we're getting 13-ish volts, give or take. Which seems slightly high because my lab power supply is set to 12 volts. Why am I getting 12.8 volts in here? Odd. But, okay, rather than take a whole lot more time on this, what I'm going to do is make a note for myself. Back on here. Here we've got to do, and the to do is going to be change passive PoE to VA pair instead of VB pair. Okay. So that should take care of situations where the PoE injector is only injecting on one pair instead of on two pairs. Typical passive PoE injectors inject on two pairs, so I'm kind of surprised that this one is only injecting on one. But, oh well, that is the way it is. So what we'll do is we'll move on from that. There's no point spending a whole lot more time on that. I'm going instead to look at the active PoE. So get rid of this. I'll switch back to that short cable because it's more convenient. Get that out of the way. Grab myself PoE injector, and what else do I need? I need somewhere to plug it into. I still have to put a power board above the bench. I've got to get under the bench to plug this one in. All right, so this is now powered up where it should be. Yep, green LED is on. Now, because we're injecting 48 volts here, this is where there is potential for stuff to go kind of smokingly wrong. Oh, I got to remember to take off these. If I don't take these off, this is one of the limitations of the design. I really don't like this. And there is a way to solve this problem, but I'm not going to get into that right now. I don't want to have those jumpers there. I want to replace this module and this voltage regulator with a new voltage regulator that can handle anything from 12 volts to the 48 nominal or 54 volts coming in on this PoE. Anyway, so here's the test. Which one is it? Switch and LAN. So I want to plug it into here, and we're about to stick 48 volts into this. Let's see if it goes boom. Ooh, it doesn't. Let's see if the LEDs come on, which will indicate that it has finished booting. Come on, Pi, you can boot. We got power. Yes, look at that. So we are now powering this over PoE, 48 volt PoE coming into the network socket. So that's nice. I'm going to do well, we know it's working, so this is kind of moot, but I'm just going to have a quick look at the power rails. Where can I find myself some convenient ground? Oh, there is a convenient ground right there. And there is a convenient 3.3 volts, and I'll just try not to short this. Unfortunately, you can't see this multimeter value. Come on. I'm really trying not to short these leads out because I don't want to short that 3.3 volt rail. Ground, and I'm also trying to do it without sticking my head under the camera. Oh, I can't get a connection on it. All right. Oh, I know where I can measure. I've got 5 volts there. This is the level shifter for the RGB LEDs. So I need to find myself a nice solid ground connection somewhere. Where is a ground connection? There'll be one at the negative end of this capacitor. So I'm just going to get myself a ground connection there. Measure there, 3.4 something volts I'm reading on that one, and this one I'm reading, come on, where's the connection? 0? How can that be reading 0? Unless that is the, what is going on with this resistor? Oh, there we go, 5.1 something volts. Okay, so our voltage rails are good. We are now running powered off PoE from this, and that means we can come back to here and say okay, but I should also, oh hang on, no, I'm going to say okay on that one, and I'm going to say fail on that, and with a note, change passive PoE pair. All right, and that is something that I will do in the design. Oh, something else that I should do, just because this is also notes to myself, power LEDs, fail. Decrease brightness. So I'm kind of fudging this and using this validation list as a to-do list as well. Just things that we're discovering as we're going through this. Now, where are we at? 11:53. We're almost at 2 hours. What is going on it? Yeah, Stephen said the PoE regulator will have 2 bridge rectifiers on it for VA and VB. Yes, that's correct. Perhaps you need the same for your passive PoE. Also allows for center positive and negative swaps. Yes, that is true. So what I could do is take I could put 2 bridge rectifiers on the board. And that way it doesn't actually care what the polarity is. It should always be safe. So I'm just thinking about whether that is worthwhile from a complication point of view. I do have some nice little surface mount bridge rectifiers. What, maybe they're in this box, I can't remember. 58 rectifier, no. Bridge rectifier, here we go. Oh, this is only 500 milliamps. Yeah, I've got these tiny little surface mount things. I've got a pack MB1S 100 volt 500 milliamp bridge rectifier. I think rated a bit higher than that. Those are, and I'd need 2 of them, as Stephen pointed out. So Scott says next revision of the board test points. Yeah. Aaron said, do we have the Ethernet chip working yet? No, we don't. Yeah, so Trady Trev said it'd be pretty mad working on all PoE types. Yes, so this is something that somewhere, I've got to find it. I have had a browser window open for ages. I'm just trying to find where it is. Oh, is this it? Yeah, because there is this new voltage regulator that is coming out, which looks like it is going to be amazing. Here we go. And it's not available yet. So this and this. Okay, so this thing, this LM5013 Q1, come on, let's get some readability happening here. So it's a automotive voltage regulator, up to 100 volts input, 3.5 amps. So it can handle some pretty serious power. Non-synchronous buck DC-DC converter. And it handles, check this out, this is the killer. This is what makes me think this voltage regulator is going to be my new favorite thing in the world. Takes in 6 volts to 100 volts. How cool is that? So what that means is that if we set the output voltage to, here's an example circuit. So V8, V out 12 volts and up to 3.5 amps, V in 15 volts to 100 volts. Now it's a buck converter, it's not a boost converter, which means, so it says here 6 volts to 100 volts. It doesn't mean that you can send 6 volts into it and get 12 volts out. You still need a couple of volts of headroom. But what it does mean is if I replace the PoE regulator module, so that DP1435 that is currently there, and the existing switch mode regulator, the 5 volt regulator, with one of these, then it should be possible to accept anything from, well, we need 5 volts out. Allowing for a couple of volts of headroom, it would mean that you could feed anything from 7 volts to 100 volts down the wire and it would work, which would be friggin' awesome. So then it needs the signaling for the PoE standard too. So if you do plug it into an Ethernet switch, which under F standard, it will supply enough power to it. But that's not a problem, that's just like a resistor across. I can't remember the exact circuit, but it is really simple. It's something as simple as a resistor across here on the Ethernet cable, and that tells the injecting device to supply enough power. So this I have been waiting for. It's one of those things that has been listed as coming soon for a while. Let's have a look at Octopart and see if there's anything listed. It was listed as like end of, oh yeah, there's the evaluation module. MOQ. Oh, there is actually stock at Mouser of the eval module. Let's see, because I don't think the, yeah, inventory history unavailable. I don't think the part itself has been available yet, but maybe eval boards have been. Yes. Oh yeah, Australia. Hopefully that, come on. 53 can ship immediately, 14 on order. So this is an eval module. There was a very good point. Stephen said you would want to have isolation for 802.3 AF PoE though, not tied to the remote side 0 volt reference. Yes, that is a good point. Yeah, so Tony said also need to handle PoE handshaking. Yes, but that can be handled very, very easily. The handshaking is not particularly complicated. So this reference module is giving us 12 volts output from 15 to 100 volt input. So this is an implementation of that reference design, I believe. But what I want to know is availability of just the chip on its own. So let's just see if Mouser have anything. LM5013 switching voltage regulators. Yeah, expected. Oh, they've pushed it back. That's sad. See, we've got expected date 13th of the 2nd, so 13th of February 2023, 4,780 expected. Now the price on these is kind of ridiculous. It's we're in single quantities. This is Australian dollars, $9.69. In quantity of 100, it's $7.13. And I think the external parts required for this are very minimal. And yes, that is a really, really expensive voltage regulator. But looking at what it does, if it can solve a whole bunch of problems, like having, at the moment I've got 2 voltage regulators on the board and I have to put jumpers on it to switch between the two. So either using the 802.3AF module or using the other regulator. If I can simplify the whole design, have a single voltage regulator that just takes anything, then that, like $7.13 premium. So $7.13, we take away the PoE regulator module, so the DP1435 goes away. I can't remember how much they are. They're probably like $5 each, give or take. And then the other switch mode regulator goes away. There's a couple of dollars gone there. It is possible that this will end up being cheaper, even though it's nearly a $10 part in quantity 1. It could end up being cheaper than the current system with the multiple regulators. So I know I'm going on and on about this, but I am really excited about this part. I want this little voltage regulator. It could become my new favorite thing. Yes, hang on. Cable Tie is complaining about whether it's lunchtime. You only just arrived. What are you talking about? Oh, Greg said, I don't trust the expected dates anymore. I've had some pushback on some parts for over 18 months now. Yeah, there are some parts that we've been waiting for the water cannon project, and they have been, we've had them on back order, and every month they get moved back by 1 month. So this particular part is one that is always, it's going to be shipping next month, and then next month arrives, and then it's going to be shipping next month. So Greg, you are absolutely right. You cannot trust these expected dates. And last time I checked this, the expected date was, I think it was November this year, like it was literally this month. And so, because I first saw this part earlier in the year, and I thought, oh, it's so far away, it's going to be end of the year, we'll have this available sometime around November. And now, of course, we're in November and they're saying February. And then by the time we get to February, they'll probably be saying May or June. Oh. All right. So, yeah. And Stephen said, but you need to find a way to isolate the supply. Yes. So for compliance with the 802 PoE specification, we need to isolate the supply and not have the common ground tied through on the regulator. Yes. All right. That's a problem for future me. And I'm still excited about this part. Now, where are we up to? Get rid of that. Where are we up to? So where we are up to is, let's go back to the mood lighting, and we are now, you can see the scan frequency of the monitor that's illuminating my face. We'll go back to that. So we now have this powered by PoE, but we do not yet have the Ethernet itself validated. And we're missing a couple of things. So, fail to do, MAC address ROM. Yeah, it's now after 12 o'clock, so I am going to stop before doing any more. But the big thing, maybe what we should do is make the aim for next live stream to get the Ethernet working, because everything else is just It's just cherries on top. It's really the WISNet Ethernet chip that that has to work for this whole project to be viable. These other things like changing the PoE pairs, that's trivial to fix. Getting things like the MAC address ROM, I think that can be solved. Getting the temperature sensor, that really doesn't matter. It's just an extra. So I think that what we should do is next Sunday we will. Oh, interesting. Austin just said found the issue with the schematic. VA and VB are wrong. Wow. All right, just before going, let's check that out. That is quite possible. So, what have we got? VA, VB. So I've got VC plus, so pin 6, 7. Yeah, looking into this is going to take a little bit of poking around in the datasheet for this part. But Austin has used this same, at least I'm pretty sure Austin has used this same connector. Oh, you can't even see what I'm looking at. What am I doing? So this is the Ethernet connector. And we've got VC1, VC2, plus and minus, going to VA and VB. So what Austin is saying is that I have screwed up and I've put VA where VB should be and vice versa. That is very possible. So I will check that out. In fact, I'm going to make a note. Here we go. I'm going to make a note. Check VA, VB swap. Okay. Yeah, I won't do that right now because I could spend the next 20 minutes digging into that. And we should wrap up because it is... Oh, DIY said, hey John, I'm working on getting a 5500 module and Pi 0 to see if I can't get it to work. Awesome. If you can get it to work, yes. Right. Oh, an Englishman in Brazil said, DigiKey UK are saying 6 weeks for the chip. Yeah, I haven't had a look around at in the past I have, but now obviously I need to look around at where it is available. Sorry, Aaron, you asked this question earlier. I know. Aaron said, any progress on the pick and place? No, I have not connected the computer back up to it to do testing after changing the protocol parser, like the and I need to do that. The thing is that the other pick and place machine, Mick will Make It, has been running hard for the last few weeks. I've been assembling lots and lots of boards, and I've had my son Tom in here. He's been running it, and so the machine, the Mac Mini that runs Mick will Make It, is the same one that I've been using to do the experiments with the KO pick and places. So I need to take the Mac Mini off Mick will Make It and put it on the KO to keep working on that protocol converter. And because the machine has been in use, I haven't really had an opportunity to do that, but I will get back to that. So Austin says, you have VA, VB swapped. Currently you're trying to tap DIY on the center taps and not 4, 5, and 7, 8. That is very interesting. Thank you, Austin. That's I am going to copy and paste your comment into my notes file there. And I'm going to credit you with that so that I can look into that in detail some other time. But not now on the stream because, just looking up at the camera, at the view of the security camera out the front, it's looking a little bit overcast, but I think it's still a nice day. And it is Sunday, Oh, okay, thanks, Austin. So Austin said, we'll DM a photo. Cool. Yeah, I'm sure that we can get that sorted out. It'll be because I have made a stupid mistake and I've screwed up the pinout on the Ethernet socket, misread the data sheet or something annoying like that, and I'm just trying to take power from the wrong place. We definitely do have power on it, as I showed when I stuck the multimeter on it, and I just need to be taking it from the right place. Michael says 21 degrees in Geelong. Yeah, I think it's about that here as well. Just a little bit overcast now. It was beautiful and sunny for the morning. But I am now going to venture out into the world because I was here at the lab almost all day yesterday. I've been doing long hours here for weeks now, and I need to get my brain out of this place. There's so much to do, so many interesting things to do, but it's not healthy to be constantly just here on the tools, doing stuff, solving problems. I need to get my brain into a different mode, so I'm going to go and hang out somewhere other than here at my bench. And yes, Richard says, John's out to the big room. I'm going to go out to the big room with the blue ceiling and the big sort of orangey coloured light in the corner and see the world. I hope you all have a fantastic weekend. Thank you for coming along to the stream, and also a really big thank you for the memberships. So I'm just scrolling back here. So Jeff Miller, who signed up as a silver supporter, DIY in the Ghetto for the $1.99 cup of coffee, Johnny for the 100 secs, and the big one, Richard, for gifting the 10 Superhouse memberships, which is fantastic. That's really generous. I appreciate it. And those sorts of things do make a big difference to me. All right, get some tan. Yeah, get some vitamin D. Okay, I'm going to hit the big end button now because my voice is failing me. Go and make something awesome.